Inventec D です。よろしくお願いします。Okay, I'm sorry, that's the best English I can say. Okay, so please allow me to use English to do the brief conversation, and we would like to share with you what kind of FPGA solutions we are going to have now, or what's the idea of the FPGA solution we think in our 5G plan, in the 5G world. Please allow me to change that. I need it. Oh, I see. Okay. So at the very beginning, I would like to share with you a very short company introduction with Inventec. So we are founded in 1975, which is kind of history, and our paid up capital is about 1.2 billion US dollars, and our revenue is about 16.8 US dollars is last year's record, and our global employees over 45,000, and our engineers is over 7,000. So we are a global manufacturer, especially for the, maybe next slide I can share with you, yeah. And I'm here, we from the enterprise business group, and our main product is about server, storage, networking solutions, things like that. And the whole group, we got almost everything about the electronic devices like IoTs, consumer devices, PCs or notebooks or things like that. So here is our global scale that our headquarters is in Taiwan. Okay, so our production campus is in Taiwan, Shanghai, Nanjing, Chongqing, and the Czech Brno, Mexico, Juarez. Yeah, it's our production campus. And the regional office in Silicon Valley is in San Jose, Santa Clara, and Austin in Houston, Tokyo here, Beijing, Nanjing, Tianjin, and Xi'an is in China. Okay. Their innovation and patent portfolios. Since we got that many engineers, so we got many patents every year. So actually, we are top 10 Taiwan invention patent applications, and we are in top 3 of the Taiwan OEMs, and we are in top 1,000 in US, and we are top 500 in PwC report. So that's a very quick introduction. Okay, so here's the final page that I would like to mention is about the world-class competence and the manufacturer. Since we got a very complete lab for every kind of competencies or like certifications. We got acoustics, we got electrical, magnetics, we got almost everything that we will need to have for our product. So you can rely on us to do the certification through us, or to see what kind of special requirement you need. We can fulfill that. And of course, we are the world-class manufacturing in this industry. Since we are in enterprise business group, so here is our main products: servers, like solutions, storage, AI solutions, switch, network solutions. And what kind of PC model we can provide for you is from OEM, ODM, JDM, CM, or even bigger models. We have complete off-the-shelf products can be provided. Don't worry about the MOQs, and I think we can fulfill them for your requirements. Okay, so here we come for the FPGA in 5G. Okay, 5G is a very complicated world, and there's newcomers wish to have their virtualization or software-defined solutions to inject into this field for services. So as a hardware provider like us, we are of course with very good relationship with those tier 1 chip vendors. So we come out some solutions, unique solutions for this field. Okay, oops. Okay, so for the 5G today, there should be an animation anyway. Okay, so for the 5G, talk about the 5G today, we would think about the SDN, software-defined network and edge computing, which included like NFVI, things like that. And talk about these two topics, then we must think about it a little bit further, that a customized or some customized features or some might be required in this field. For example, like telcos. Every telcos now have their own logic or their own process for example, like billing systems. And maybe you want to put some special features into your, maybe virtual RAN or some technology you try to adopt today. Then you have the customized features. Of course, you can run in the CPUs, but if you want to chase for better performance, then maybe FPGA is a good answer. Or the computation complexity. Okay, it's about edge. When you talk about edge computing, you think about the AI. You think about many kind of different things, technologies you try to use and adapt it into the edge. So the computation is not simple. So maybe FPGA is a good answer for that. Since and more, we wish to address for FPGAs the high flexibility with a very high performance. We know CPU can do a bunch of things, but the performance may not achieve the 5G criteria, like ultra low latency. That's a very, very, very challenging thing. So 5G is an answer. Okay. Here is I would think that everyone here is very familiar with these things. Like ASIC is very high performance and high power efficiency today, but the scale is big, which means you must deploy a lot, buy a lot to get the cost efficiency. For the CPU, it's very high flexibility. You can use any language you like familiar with like Python, like C, C++, things like that, and very easy to update. Okay, but FPGA is something in between. Programmable, it can be updated, and the performance is good between ASIC and CPU, and you got your cost efficiency. Okay, and 5G application is most about networking. And some of the best solution is to integrate FPGA into a smart NIC, because it's most about the networking in the 5G. Okay, so to answer this FPGA, Inventec have our own smart NIC design. Here is I try to introduce you our FPGA smart NIC design. Okay, what is a smart NIC? A smart NIC is, of course, a regular NIC card plus a brain, or maybe in some intelligence, which means to be smart. Okay, it's easy, right? How and what kind of help they can do for you? They can do CPU offload. They can do any acceleration or your customized networking behavior. Actually, we push this product into some China data customers, and they do have their customized features. Okay. So we already have it today. Yeah. So, what's inside it? Take a look. Actually, with this smart NIC card, our product code is X250, and actually has a NIC controller plus a ARM CPU, which is a product from Broadcom Stingray. It's a launched product. You can find it on the web for further information. Plus a FPGA. The FPGA is from the Intel Altera today. Okay, the good news is that this ARM is running an embedded Linux. Actually, it's a Yocto Linux base. Okay, and it's exclusive. You cannot find the same product in the market now today, maybe later, but you cannot find it now. So I think it's very challenging product to do that. Yeah. Okay, so let's even take a closer look. So what's the special in this SmartNIC? Okay, this is that I don't mean to dive too much technical details, but I think it's very valuable to share with you that our special design, very unique design, that actually we have a PCI link, we have a link between the controller and the FPGA. And we also have another links independently from the controller and FPGA to the x86 CPUs. What's the beauty of it? Because you can treat them as two very independent devices, which means if you want this FPGA, you want to help controller to do some features, of course you can use this link. If you are trying to do some CPU offload, you can use this path, or you even can link all the paths together, or even better, you can cut the FPGA into two parts, and some parts helping the controller, some parts is helping the CPU. It's all your decision. That's a flow path. I'll go very quickly, and we can share this slide to you after this meeting. So basically, the flow comes in, and you can decide what kind of flow or after process you want to do in Stingray, or what kind of after process you want to do in FPGA. Then they pass the data or the traffic to the CPU. It's all your decision how to use that, and vice versa. So, and with that SmartNIC, how can we use into, how can I plug it into our services today? Okay, so it's a standard half-high, half-length, oh I'm sorry, there's a typo, there's a 4-high, half-length PCI form factor, and you can easily install it into any standard 1U or 2U servers. Okay, so that's a real case of our customer trying to use the customized encrypt or decryption feature in the SmartNIC with network features. Okay, and the logic inside can be updated because for some data center customers, you may face a problem that okay, if one day, for example, says today, I have a hardware. Special defined hardware for some special like encryption function to embed it into the card and into the system. What if next year I wish to upgrade this encrypt or decryption function into version 2? How should I do if that's a dedicated hardware? Then nowhere to do that. So you can use this SmartNIC, you can use the FPGA programmable feature. You can upgrade or update your features inside this card. Okay. Prototyping. Prototyping is also a very important thing in that SmartNIC because you can easily foresee that we develop some FPGA feature. We need some time. And the logic itself. The certification needs time. So remember we have an ARM inside. It's embedded Linux, so you can run in any language you like. So you can prototype your logic in the ARM server, ARM, and then try to migrate it to FPGA after you validate your logic. So that's a good thing that our FPGA SmartNIC can provide. Okay, Second use case is in edge computing. In edge computing, we wish to do the networking of load. So you can put that into the SmartNIC, or you wish to have some AI acceleration, you may put into the SmartNIC FPGA part. Or even you can use the embedded Linux if that's an easy task. You may use the ARM to do that. Yeah, you can try to meet your performance request. Okay, storage acceleration. Yeah, this SmartNIC can become a SmartNIC, a storage acceleration. For example, you can access the remote storage for another SmartNIC and to provide the storage to the host. So that's an idea. And this we can moving on to next stage is that. Okay, so you can see the NVMe today is very small. It's very small. So we can squeeze it all into a 2U system. For example, that's a 64 NVMe hard drives. With this model, we can hook these NVMe hard drives and let it become part of the pool storage. Yeah. Okay. Edge in 5G. We talk. Previous speakers talk about lots of things of the real use cases in 5G, right? So don't forget that Inventec is a manufacturer. So we do have a factory. We have a factory. Okay. So we learned about that 5G is very, there's two things that 5G is good about is ultra bandwidth, ultra broad bandwidth, and ultra low latency. With this low latency and this big bandwidth, we try to adopt it into an edge computing. And when we said about edge, we must consider public cloud and private cloud. For public cloud, the validation is a long way to go because the service itself is complex. But the private network, for example, like smart factory, right? Smart door control, right? Smart factory. I think those kind of use cases might be happen quicker, just like Inventec. So we are trying to do some industrial vertical integration with those service or applications into 5G. When we talk about that, we must address AI and AR, and of course SDM. Okay. No matter what kind of service we try to adapt, Inventec do have those products to support that. And we, of course, seeing 5G is a trend that will boom up. So we are turning our product lines, we are adding our product lines especially for those 5G solutions. Okay. 5G lab in Inventec. So since since we are trying to adapt those 5G solutions into our hardware solutions, so Inventec do have a product lines like that. So we are going to establish a 5G lab for real playground with 5G solutions, especially in RAN, especially for those performance or those validations. So we are trying to converge our traditional product line. Of course, it's automated. It is already automatic, and we are trying to adapt 5G solutions into it with those RAN solutions with AGVs to communicate with. That's a real traffic. We have a smart center, and that's real traffic flow to do the practice. Here is the real deployment we are trying to do, and what we trying to address is that we can have all kind of devices using the 5G as a channel and to do the real data traffic to the backend, like in edge computing, we have 4 product lines to support, or the small rack in RAN. Okay. That's all I have today. Thanks for your patience. がとうございます。